Hello everyone, welcome to Catalyst Chemistry. As we discussed last class, important point about a wave number. Next one is what electromagnetic spectrum, and the next one is what particle nature. In this case, important point is what the wave number. The wave number is represented by nu bar. The nu bar equal to 1 by lambda. The reciprocal of the wavelength is called what? Wave number. Okay, the wavelength in per unit length, that is the definition of what? Wave number. Next, after that, electromagnetic spectrum. Electromagnetic spectrum, the important point is what? In this case, what if you are going to take along this line, in that case what the wavelength is going to what? Increases. Means in this case what, you know very well about that column is there, last video, that is most important is what? Gamma rays is there, X-ray is there, IR is there, UV. Next one is what? Visible light. After that what? FM, frequency modulation. AM is there, that is called amplitude modulation. Frequency modulation, amplitude modulation is having a higher wavelength compared to what? That is gamma rays. Okay, that is most important. Usually they are going to ask you question very simple, what is the in general wavelength of visible light? The visible light in general wavelength is 400 nanometer to 700 nanometer. Okay, that is called in general wavelength, that is visible light. Okay. UV visible, UV is there, that ultraviolet, okay, that is important. Next, after that what? Particle nature. You know very well about that light is having a dual property. One is what? Wave, another one is what? Particle nature. Interference, diffraction, these two things are explained with the help of what? Wave number of wave nature of light. But in this case what? Black body radiation is there, photoelectric effect is there. Okay, one more is there, what is that? Line spectrum. Okay, all these things explained with the help of what? Particle nature of light. Okay, in that the first one is what? Photoelectric effect. After that we are going to study about a Planck quantum. Next one is what? Black body radiation. At the last we are going to study about a spectrum. In that what? Atomic spectrum, line spectrum. Okay, just here in this case important point is what? Photoelectric effect. Photoelectric effect, it works on particle nature of light. This is most important point. Okay, in this case particle nature means, you know very well about that light is act as a dual property. One is wave, another one is what? Particle. Particle means what? It is a move as like a bullet, that is most important. Okay, just here in this case heading is photoelectric effect. Okay, photo means what? Light. Electric means what? We have to supply electric current, okay, along with help of what? Battery. Just here, that is in this case photoelectric effect. This phenomenon was expressed by what? Hertz in what? 1887. Okay, just here this is a diagram of what? Photoelectric effect. Just here in this case they are going to consider one tube. Okay, that tube containing what? One is what? Positive, another one is what? Negative. This positive is indicate what? Detector. This negative is there, no, this is act as a what? Metal surface. This one is indicate what? Metal surface. In this case they are going to use what? Metal surface. Before this point I will tell you, solar system completely works on photoelectric effect. This is a very good analogy. Okay, that is most important. In this case if you are going to consider solar panels are there, no, solar panels, in that solar panel is there, that panel containing what? Metals. That panel containing what? Metals, but what kind of metals they are going to use, that is most important. That point we will study. That question asked in one time JEE mains exam. Okay, in solar panel usually in solar panel which metal they are going to use, the answer is very simple, that is cesium. Here is there, I will explain later. Okay, just here in this case what? This is the diagram. Okay, after that in this case they are going to consider this one. In this case what? They are going to consider one ammeter. Ammeter means it shows what? Deflection, how much current is going to pass. Next, after that they are going to use battery. What it indicates is long line is there, no? This is called indicate positive, very smaller line is indicate what? Negative. They are going to use, this is negative, positive, negative, positive. Means in this case they are going to use high voltage battery. Indirectly what? High voltage battery. This one is shows. Next, in this case what? Here is what? Metal surface is there. Here is what? Positive. Here is what? Negative. They are going to use what? Electrode. Just here in this case metal surface means, in this case this metal may be a potassium or may be a rubidium or may be a cesium. Okay, next after that in this case what happened? The light is fall on this metal surface. This is indicate what? Light. Light means don't worry, this is what you the light come from sun only, that is indicate what light only. Okay, that is act as a what particle nature. The light fall on this metal surface. When light fall on this metal surface, metal start ejecting electron. Ejecting the electron means indirectly donate the electron. That electron move in a water in a particle nature. Okay, that's why in this case the electron move in this direction. The electron move in this direction means electron is a negative. That negative moves towards a what positive. Okay, this is the what mechanism. That is in this case what this is the entire. Next in this case what all the points is there for notes purpose only. Okay, I am going to read one by one point. This is the what most important diagram. Okay, in examination also they are going to ask you, make it practice. Okay, this diagram very simple is that this is positive, negative, this is one is indicate metal surface, this one is the what light, the electron move from what this metal surface to this detector. In this case what is there, no detector. When this electron is going to hit this one, hit this detector, automatically it can start what donating what receiver. It can start giving message to what this emitter. Okay, that's why they are going to use what detector. This one is indicate what battery. Just here in this case the first point, when certain metals means what, it may be a potassium or may be a rubidium or may be a cesium. In this case they are going to use the metals, that is most important. They are not going to use the non-metals, they are going to use what metals. Metals means it can donate electron, that is what very simple thing is there. But in this case they are not going to use iron, cobalt, such nickel, such kind of metals. Why they are not going to use? Those metals will not donate or will not ejected electron very easily. In that case we have to supply much amount of energy. You know very well about that in a solar system, if light is not there that much, but also solar start what it's receiving energy. Okay, that is what most important. That's why they are going to use what potassium, rubidium, cesium metal. In solar system they are going to use what cesium metal. This is what CS is indicate what, this is a cesium metal. Okay. Next in this case what, when certain metals like are exposed to a beam of light, means what, this one is indicate what, a beam of light, they emit electrons, means they start ejecting electron. This phenomenon is called what, photoelectric effect. Very simple is there. When light means when beam of light is fall on the metal surface, metal start ejecting or donating electron, that is called what, photoelectric effect. This is called first point you have to write. Okay. Next one is what, second point is there. Second point means what, the electrons are emitted as soon as the light radiation strike the surface of the metal. When this light strike or fall on this metal surface, as soon as immediately start what, donating electron, because of this metal is a very important role. Next after that, the number of the electron emitted is proportional to the intensity of the incident light. This is most important point. The number of electrons are emitted is directly proportional to the intensity of the incident light. If the light is having a more intense, it can donate a more electrons. If the light intense means this is having incident light intense is a less, means it can donate electron less only. Okay, that is most important. That's why in this case the number of electrons emitted here is there, no, the number of electron emitted is completely depends on what, incident light, intensity of the incident light. That is most important. That's why this light and this ejecting or donating electron, these two are directly proportional to each other. More number of light is there, more number of electron donate. Okay, this is most important. Next after that point, third point, this is first, this is totally second point. If you want you can make a sub point, no problem. This is the third point. Okay, for each metal there is a characteristic minimum frequency. For each metal, if you have to consider each metal, every metal is having a what, characteristic minimum frequency is, that is known as threshold frequency. The threshold frequency is represented by what, nu naught. This is a nu naught is there, that is indicate threshold frequency. Means for every metal is having a what, minimum characteristic frequency. That minimum characteristic frequency called what, threshold frequency, below which photoelectric effect is not observed. This is most important. If you are going to use a iron or such kind of metals, means there is no what that metal is not having a that much threshold frequency, that is why they are not going to use. Below that threshold frequency, photoelectric effect is not exist, means when the light fall on the metal will not ejected, will not donate the electron, means there is no use of photoelectric effect. The photoelectric effect means what? The light fall on the metal surface start as soon as immediately start to what? Donating the electron, then only they called photoelectric effect, otherwise they don't call photoelectric effect. Okay. Next, after that, at frequency nu is greater than nu naught, means what? In this case threshold frequency is less, the ejected electrons come out with certain kinetic energy, means in this case what? Threshold frequency is less, but this frequency is there no general frequency, that is having a what? Means what? Normal frequency is greater than what? Threshold frequency, that time what? The ejected electrons having a some kinetic energy. Kinetic energy means what? Start moment. Okay. The kinetic energy of this K is indicate what? Kinetic energy of these electron increases with increase in the frequency of the light. Very simple. In this case, this every electron is having a what? Kinetic energy. Kinetic energy means what? Start moving. Okay. That's why in this case important, this light frequency compared to our threshold frequency, greater than threshold frequency, means obviously in this case this electrons having a what? Kinetic energy, ejected electrons having a kinetic energy. Up to this is called what? Photoelectric effect, friends. Okay, make it perfect. This is a diagram, they are going to ask you what? 3 marks question for what? PU level. Make it perfect. Okay. If you want, you can take a screenshot. I will start the next concept, that is called Planck quantum theory. After that is their blackboard radiation. Next one is what? Problems. Okay, you have to take screenshot. Okay. Next point, friends, Planck's quantum theory of radiation. This is also most important part. Okay. In PU board they are going to ask you what? 3 marks question, you have to write 3 postulates. Okay. Just here in this case the important point is what? That is Planck's quantum theory of radiation. In this case the quantum theory of radiations was proposed by what? Max Planck in the year of what? 1900. Okay. In this case most important point is what? Energy is released. Energy is released means what? Light is also one form of energy. Energy is released in the form of packets or a quanta. These words are most important. Energy is released in the form of packets or a quanta. Okay, means where this energy come from? This energy come from the what? Light source. Okay, that is important. Make it perfect, this definition. Energy is released in the form of what? Packets or a quanta. Next, after that they are going to ask you what? The main postulates. Totally 3 postulates are there. Every postulate is the most important. Just see here in this case, electromagnetic radiations, first postulates, the electromagnetic radiations are emitted, absorbed and propagated discontinuously. This word is important, discontinuously in the form of small packets of energy. Each packet of energy is called a quantum or a photon. This is a what? First postulate. Just see here in this case what is the meaning of this first postulate means, just see here. Okay, in this case I am going to put one plate like this. Okay, next after that in this case here one person is there. Okay, next after that in this case what? This is a source of what? Radium gun. We have to use like this gun. Okay, you have to consider this is what? Act as a gun. Okay, this is AK-47 gun, you can consider, no problem. Okay, this is what? Gun. In this case what? Gun is having a what? Bullets. Okay, the bullets come from the what? Gun. Okay, in this case bullets come from the gun means that bullet is act as a what? Wave or a particle? Particle nature. This when he start, okay, he start press the button, automatically what? Bullets come from the what? Gun. The bullets come from what? In this case what? Continuously or discontinuously? Discontinuously. Discontinuously means in this case one bullet go out from the gun, the next another bullet will come, the next what? Third bullet, fourth bullet, so on. Okay, if you are going to press in this case what? AK-47 means in this case 47, if just you have to assume 47 bullets are there. If you are going to press like that, all the 47 bullets come from at a time? No, that is not like that. In this case, what the bullets come from the gun one by one. That is word is indicate what discontinuously. Okay, if you are going to hear is there, in this case what one bullet come from hit this one, hit this plate, and it fall down. Next after that what, in this case what, another bullet come again hit this, next one is what, fall down. Okay, that is indicate in this case what he is going to, this person is going to assume that in this case bullets are coming what, discontinuously. The bullets are coming what, discontinuously. Okay, that is what most important. Electromagnetic radiation, light is also one form of what, electromagnetic radiation only. The electromagnetic radiations emitted, absorbed and propagated discontinuously. Means in this case just you have to consider here tube light is there, the energy coming from the water tube light means what, in this case I am going to assume that the continuous, not like that, that is light is what, discontinuous. Okay, in the form of what, small packets of energy. Okay, each packet of energy is called what, quantum or a quanta or a packets, or one more word is there, that is called photon. Why you are going to use this word photon? Means in the light case we call it as a photon. In the light case we call it as a photon. This is the first postulate. Make it what, perfect. Next one is what, second postulate is there. Each quantum of radiation means what, in this case means when we are going to, this is there, no, in this case we are going to call the what, this is indicate what, a quantum of radiation. Each quantum packets. Next one is what, photon. Each quantum of radiation is associated with a definite amount of energy. If you are going to consider, means in this case this bullet fall down means what, this bullet is having a what, definite some amount of energy, no. That's why in this case associated with a what, definite amount of energy. That energy is represented by E is equal to H into nu. This formula is the most important, E equal to H into nu. This one is indicate what, each quantum of radiation. Next, where H is indicate what, Planck constant, the nu is indicate what, frequency of radiation. Okay, what is the value of Planck constant? H equal to 6.626 into 10 to the power of minus 34 joules second. Okay, this is most important. Bear in mind this value is the most important value, that is indicate what, a Planck constant value. The Planck constant is represented by what, H. Value is what, 6.626 into 10 to the power of minus 34 joule second. This is what, third postulates. The next one is what, fourth postulates. A body means what, in this case you have to consider body means what, any every, this bullet is as like a what, body means a body emits or absorbs radiations, means what, this one is considered as what, emits or absorbs radiation only in the what, integral multiple of quantum. That is indicate what, E equal to n h nu. In this case E equal to h nu, in this case what, n. This n is indicate what, that is the number of photons. Number of photons, where n equal to 1, 2, 3, so on, that is indicate number of photons. Up to this is what, Planck quantum theory of radiation. Two things are most important. The first one is photoelectric effect, the second one is what, Planck quantum theory of radiation. In both the cases the light is act as a particle. This is most important point. Okay, bear in mind. Okay, the next part is there, that is black body radiations. That is also completely depends on what is that particle nature of light. Next after that I am going to solve problems. Okay friends, subscribe and promote the channel. Thank you.